Alright, so we covered what the definition of a derivative was, so now let's just go over some of the basics of differentiation. So let's take a look at a couple of the notations first, just so you understand when you see them in a problem. So let's say that I give you the function f of x, and I ask you to find the derivative. The derivative can be written as this, just f apostrophe with an x after it. If I ask you to find the second derivative, which is basically the derivative of the derivative, then that's just two apostrophes. Now, if I ask you to find the derivative of y, then there's a bit more to it. So you may recall that the delta symbol means change. So for example, the change in y can be written as delta y. We know that the slope of a line is the change in y over the change in x. In other words, the average slope, the slope of a line, is delta y over delta x. The derivative letter d means an infinitely small change. So dy over dx is basically an infinitely small change in y over an infinitely small change in x. In other words, if I ask you to find the derivative of y, then that can be written as dy over dx. So I previously mentioned this long formula that we could use, and I explained how we came to it, but there's actually a much simpler way than using this formula every single time. So we're going to take a look at the power rule. So if I were to tell you if f of x equals x to the power of n, then the derivative of that is basically n times x to the power of n minus 1. So all you do is take that derivative, you put it in front, and then you subtract 1 from that derivative. So if I ask you to find the derivative of x squared, then you take the 2, you put it in front, and you subtract 1 from this right here. That leaves you with 2x to the power of 1. If I were to ask you what the derivative of f of x equals x cubed, then the derivative is obviously x squared. X to the fourth goes to 4x cubed. X to the power of 1/2 turns to x to the power of negative 1/2 times 1/2. There are several important rules, and k represents a constant in these rules. So if f of x equals x, and I ask you to find the derivative of this, then that'll just equal 1. Okay, the derivative of x is 1. You can just apply the power rule to this to see if it works, right? Rule number 2, if f of x equals k times x, then the derivative of f of x equals k, right? The x goes away, the x turns to 1, as we saw up here, and the k is left there. It's left by itself. So the constant is left untouched. So an example is if I ask you to find the derivative of 3x, then the answer is simply 3. If the function is k, and I ask you to find the derivative of it, then the derivative is 0, okay? So in other words, the derivative of a constant, such as 4, turns to 0, since there's no x there. So let's take a look at the addition rule first. So if f of x equals a times x to the n plus b times x to the power of m, where a and b are constants, then the derivative of that is just, and this is just applying the power rule and the constant rule that we talked about before. Let's take a look at an example. So if f of x equals 4x squared plus 2x cubed, then the derivative of that is, you leave the constant alone, right? And x squared turns to 2x, so 4 times 2x, plus 2 times the derivative of x cubed, which is 3x squared. That gives you a final answer of 8x plus 6. Let's cover higher power order derivatives. That basically means if you have a function, f of x, the first derivative can be written as this, f apostrophe x. The second derivative can be written as this, f apostrophe x. If I ask you to find the second derivative of x to the fourth, then you basically take the derivative, and then you take the derivative again, right? The derivative of 4x cubed is 12x squared. Using the power rule, you can simply tell that. Now let's take a look at the product rule. So if f of x equals u times v, then the derivative of f of x equals u times the derivative of v plus v times the derivative of u. And you should memorize that, by the way. It's pretty common. You're going to see this a lot, actually. It seems a bit complicated, so let's hash it out in an example. So if f of x equals this big term right here, right? So we have this term right here, and we have this term right here. So you might be wondering how u and v works, right? So if you can think about it like this. If you can wrap this around in parentheses, or if you need to wrap it around in parentheses, then this can be turned into u, and this can be turned into v, right? So you could actually just multiply the whole expression and find the derivatives of each term, but that could take a long time, and it could get messy. So let's just use the product rule. So the first term in parentheses represents u, right? And the second term in parentheses represents v, right? Now let's find the derivatives of u and v. The derivative of u, using the power rule for each term, is 3x squared plus 6x minus 5. The derivative of v is 4x cubed minus 18x plus 1. Once again, we just use the power rule. Now plug the terms into the equation, right? So u is this term right here. So u times the derivative of v plus v times the derivative of u. So that's our final answer. Alright, so now we're going to cover the quotient rule. So if f of x equals u over v, then the derivative of f of x equals v times the derivative of u minus u times the derivative of v, all over v squared. So let's actually take a look at this function right here, for example. If I asked you to take the derivative of that, then you'd first let u equal the top part, and you'd let v equal the bottom part. Then you'd find the derivatives of each part. So the derivative of u is 5x to the fourth minus 12x to the third. And the derivative of v is simply 2x, using the power rule for both of these. You plug it all back into the quotient rule, and this is what you get. This is your final solution. The chain rule is actually a bit complicated, and it's actually very important that you get this. So let's say that you have a composite function, right? And a composite function is a function in a function, such as f of g of x. For example, let's say that f of x equals x squared, g of x equals 2x. So if I were to tell you that what is f of g of x, then you tell me that you just plug in whatever value you have for g of x, which is 2x in this case. You take 2x and you just replace it with g of x. And then you take everywhere in f of x where you see an x, and you replace it with what's inside the parentheses. So that becomes 2x squared. So this is the formula for the derivative of a composite function. And we're actually going to go over an example to better illustrate what this actually means. If you look at this, take a look at this example right here. First, you'd find the derivative of f of x and g of x, right? So the derivative of f of x right here is 2x. The derivative of 2x is just 2. We know that f of x equals x squared, g of x equals 2x. We know the derivative of both of these is just 2x and then 2. So plug all these values back into here, right? So you have the derivative of f of x, right? It's 2x. So then you just plug g of x into that. So you plug g of x into 2x, which is 2 times 2x, and then you multiply that times the derivative of g of x, which is just 2. So basically, these are the steps you want to follow. You want to find the derivative of f. First, you want to identify what f of x is and what g of x is. Then you want to find the derivative of f of x, find the derivative of g of x. Then you just plug them into this formula, right? But for this example, the answer is 8x. Also, let's just clarify how you can identify certain functions, because sometimes it's not obvious what f of x is and what g of x is. So for any equation where you can use parentheses, the stuff inside the parentheses is g of x. The stuff outside the parentheses is f of x. So let's say you have this. Now, it may not be obvious what is f of x and what is g of x, but if you notice, x plus 3 is in the parentheses. And then the parentheses you have to the power of fourth. That's all you have outside of it, right? So x plus 3 is in the parentheses, so that's g of x. Now, f of x is x to the fourth, right? It's everything that's not in the parentheses. And also, in case you didn't notice, you have to plug in an x there, so it makes sense. So let's take a look at sine 2x. So the inner part of this is 2x. So 2x is actually going to be g of x. Sine in the parentheses is going to be f of x. Now it's also important to note that you have to fill in the void with an x. Let's take a look at this. You can actually wrap the 4x plus 3 around in parentheses here. So that makes 4x plus 3 g of x, and the square root symbol the f of x. So let's just do two examples, now that hopefully that you got the whole f of x and g of x. If you can wrap it around in parentheses, then the stuff in the parentheses is g of x, and the stuff outside the everything that's not in the parentheses is f of x. And you have to replace whatever was g of x with just an x. So let's say that h of x equals x cubed plus 5 to the power of 4. Then what is the derivative of that? Let f of x equal x to the fourth. It's the outside of the parentheses. F of x equals, and the derivative of that is 4x cubed. G of x equals whatever's inside the parentheses, which is x cubed plus 5. And the derivative of that, using the power rule, is 3x squared. Plug the values into this chain rule formula right here. So you take g of x, which is x cubed plus 5, and you plug it in for x in the derivative. And then you get 4 times x cubed plus 5, that quantity, to the power of 3, times 3x squared, which is the derivative of g of x. And that reduces to this. Let's take a look at this example. F of x is just the square root symbol. And in other words, you can actually write that as x to the power of 1/2. That's just another way of saying the square root symbol. The derivative of that is, using the power rule, is 1 over 2 root x. And g of x is x cubed plus x squared plus 4. It's under the square root symbol, which is technically, we can wrap around in parentheses, right? So that, the derivative of that, using the power rule, is 2x. And plugging these into the chain rule equation, you're left with this. So that reduces down to this as your final answer. Let's just go over a few derivatives of trig functions. You really should memorize these. First is that the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tan x is secant squared x. The derivative of secant x is secant x tan x. And the derivative of cosine x is negative cosecant x times cotangent x. And you're just gonna want to memorize these because you're probably gonna need them for a quiz or test. Let's just do a quick example just so you can understand the chain rule used with trig functions. So if I ask you to find the derivative of sine x squared, so x squared is in parentheses and sine is on the outside, right? So f of x is sine x, and then g of x is x squared. The derivative of f of x is cosine x, and the derivative of g of x is 2x. So using the chain rule equation, you get cosine x squared times 2x. And that'll be it for this lesson. And hopefully you can do a few more examples of derivatives on your own, better clarify your understanding of how to use them. The more you come across, the better you'll be prepared for your test or any quizzes that your teacher gives you.